Welcome. In this video, we're going to talk about normal distribution and normal curves. You may have heard of them referred to as bell curves. We're going to talk about them as normal curves. And you will see two on the screen right now. One is wider than the other. The wider one has a larger standard deviation than the smaller one. So the standard deviation affects how spread out that normal curve is. One useful tool for estimating your data set is what's called the empirical rule. And if you know your data is normally distributed, then you also know that if you go plus or minus one standard deviation from the mean, which is equivalent to a z-score of 1, you should have 68% of your data points. If you go plus or minus 2 standard deviations from the mean, then you should have about 95% of your data points. And finally, if you go plus or minus 3 standard deviations from the mean, you should have 99.7% of your data points. Again, this is an estimation. It's not exact, but it's very close to what should occur. Now, this graph here is to show when you draw your normal curves about where to place your plus or minus standard deviations. Now, your graphs don't have to be perfect. You just want to be in the ballpark. So if you wanted plus or minus 2 standard deviations, your 1 should be at what's called the inflection point, or kind of where the curve changes its concavity. And let's say I was looking for what percentage of data is less than a z-score of 2. I would then shade in the area I'm looking for, because this is a density curve, so the area under the curve will give me the percent. So I would label it plus or minus 1, plus or minus 2, plus or minus 3, and then put a line where I'm looking for and shade whichever direction. If I wanted to know what percentage of data is above 2, then I would shade over to the right. All right, so let's show you how the calculator works here. First, we have to have a problem to do. All right. We want to know if Beck took the SATs and got a z-score of 2.1 on it, what percentile is Beck's score? So we're looking for the area under the curve, and to the left, because percentile is the value of your score, and below, the percentage at that value and below. So let's first approximate this. So if I have this normal curve, and we got z equals 0 here, we'll say z equals 1, so z equals 2 is about here, and we're right after that, so we're looking for this area under the curve. Now from the empirical rule, let me just draw another normal curve here. We know that at the median, first let's take the median, this is 50% of the score. And then we're plus 2, we're 2.1. So the above half, if we're plus or minus 2, we're 95%. So this is going to be whatever the 95% divided by 2, which is 47.5%. So our answer, when we get the calculator answer, should come out to be about 97.5%, because we got the 50% below the mean, and then half of that plus or minus 2, the 47.5%. So that's about what our answer, so an estimate of what our answer should be. All right, so let's get and try with the calculator. So take out your calculator. We'll keep our annotations. All right, here's our calculator. So to get to the formulas we need here, we're going to do second vars. And you will see it's distribution. So what's in the blue is when you do the second is what you get. So we're looking for distribution. and we want the normal CDF. That's cumulative density function. We never use normal PDF because that's the value at a given point. And in a density curve, since it's the area under the curve, that gives us the probability. There's no value just at one point because there's no area there. So number one, you're never going to use. All right, so number two, normal CDF. And if you remember, we go back to our picture, we're looking for this area to the left of the curve, so we're going to negative infinity. So negative 1e99 is good. Then our upper is our 2.1. And when you're doing it from a z-score, your mean is always 0, standard deviation is 1. I always tell my students, always do normal CDF as a z-score. Yes, you can get this to do calculations without a z-score by changing mu and sigma, but it's a good statistical communication to use your z-score, and therefore you can just type it in and you never have to change the mu or the sigma. All right, then you put paste. Now, if you have an older TI that doesn't have those command windows I just had, this is the order you're going to put your data in. Lower bound, upper bound, mean, and standard deviation. And then you press enter, and that is the area under the curve, and it always gives it to you as a probability, not a percentage. And usually we give answers as probabilities, but since this asks for percentile, you would give it as a percent. So 98.2%, and that is close to our 97.5%. All right, so next, what if we want to go backwards? What if we're given a percent and we want to know what the z-score is? So let's try this with a given percent. Let's do 45%. All right. So we're going to go to the same menu. You go second vars, but this time we want inverse norm. And we're going to do a percentile, so it's 0.45, and this always has to be as a decimal. And our mean is 0, standard deviation again 1, because we're looking for the z-score. And then all the newer calculators you can do left, center, right. So since we're doing percentile, that's always to the left of the z-score. Center would be if it's in between two values, or right is to the right. All right, so we paste, and our z-score, as we expect, because it's below 50%, is negative. And we'll just say it's a negative 12.5. All right, so z equals negative 12. Oh, no, sorry, I was doing percent, negative 125. So which makes sense, it should be very close to 0. All right, and finally, let's do an example. So feel free to read this, pause, and then you can come back and see if the answers are here. All right, so I'm going to go over the problems here. So the scores on the SAT verbal test in recent years are approximately normal with a mean of 500. So this is a mu, this is sigma, and a standard deviation of 110. So that's just a notation that you can see sometimes. The big N just means normal. How high must a student score in order to place in the top 10% of all students taking the SAT? So first, we're going to just draw a picture here. So we got the normal curve, and we got the mean goes 505, And we want top 10%, so something over here. So we're looking for the z-score that gives us that top 10% there. All right, so I'm going to go to my calculator. And we are going to see what z-score I get if I'm in the top 10%. So I'm going to go second distribution, inverse norm, and we're doing 0.1 to the right. Now you could also, if it's 0.1 to the right, do 0.9 to the left, and you should get the same answer. All right, we get 1.28. So let's go back. All right, so z equals 1.28. And now we want to see what the score is. So if you remember from our z formula, it's the x minus mu over sigma. So we know z, and that we're looking for the x, and it's minus the mean over the standard deviation. And now you just take out your calculator. And you should get 645.8. So that would be the raw score. Obviously, if you're talking about SATs, it's not going to be a 0.8, so it's probably 646 would be the answer. All right, so I think I have one more question for you to try. Example 2. This is going the other way. We want to see what percentage of women fall between 60 inches and 67 inches, given the mean is 64.5 and the sigma is 2.5. And then what is the height of the women in the 91st percentile? Okay, so again, you can press pause if you want. Try this out yourself and then come back and check the answer. Okay, so I'm going to do this with z-scores. Yes, you can get your calculator to figure out some of this without doing z-scores, but they're a good point of reference for statistics for you to estimate, oh, this number makes sense, and also to communicate. All right, so we want 2 z-scores, and when you're doing things like this, subscripts can be your friend. So I'm going to do the z of the 60 inches. And then the z of the 67 inches. All right, so I got to find these 2 z-scores first. And the first one should be negative, and it is negative 1.8. And the second one is 1. All right, so those are my 2 z-scores. So what I'm looking for is, if I have 0 here, is z equals 1, and then we're almost to 2 here. So I would estimate, let's see if I'm right. So plus or minus 1 would be 68% of your data, and we're plus 1, almost minus 2. So I'm going to say 80 something. Let's see if I'm correct, just in my ballpark. All right, so we have to go to our calculator. And we're going to go to this time normal CDF, and we're going from negative 1.8 to positive 1. Whoops. Oh, I did the common problem that you might have done. When you're doing negatives, you got to make sure to use the negative down here next to the enter sign. Otherwise, you will get an error. I'm glad I did that to show you. There we go. And I was very close, 0.805. And I promise I haven't figured this one out recently since before I recorded this. So that was pure estimation. All right, so from current slide. So the percentage is, so the probability that Z that we're less than negative 1.8 Z to so it's 80.5%. Sorry, it took me a second to write the probability statement. So just later on, you'll see these probability statements. So we adjust the probability that a value will fall between negative 1.8 and 1, and this should be a Z. So that our Z-score is between those two values. And when you're talking probability, it's always going to be as a decimal, but this one percent, so it's 80.5%. All right, and lastly, we have what is the height of a woman in the 91st percentile? So that is if we're over here and this area is 0.91. So we're going to get a Z value, and then we're going to work backwards and find the actual. All right, so this is going to be your inverse norm. So we're going to go second distribution, inverse norm, and we want 0.91, and we're going to the left for a percentile, and the Z is 1.34. All right, so this equals 1.34. And now we have to do the formula. So we know 1.34 equals our x value minus the mean over the standard deviation. Now some basic math. And we get x equals 67.85 inches. All right, so I hope this helped you out. And if you need to, you can go back and relook at the calculator commands. It takes multiple repetitions to be able to find the buttons, and sometimes you'll just press, normal CDF instead of inverse norm, and basically the prompts will tell you, oh, I pressed the wrong one because it's asking for area, but that's what I'm looking for. So it just means you have to use the normal CDF. And finally, you don't use normal PDF. Remember that number one you're never going to use on the second VARS menu. All right, thank you and good luck.